Alright, so this is for Pre-Calc 11, Chapter 6, Section 1. We are starting off with this thing called rational expressions. And if you remember, the word rational is just a fancy way of saying fraction. Okay, so a rational expression is an algebraic fraction with the numerator and denominator. So with numerator, I apologize for my handwriting, numerator and denominator, and in this case numerator and denominator are polynomials. Now if you remember, polynomials are just expressions that have variables and constants. Okay, so the first example says here, evaluate 0 over 3. So I'm going to turn my calculator on, and you probably know what the answer to this is. 0 divided by 3. Well, 0 divided by 3 is 0. Okay, so when you divide 0 by any number, it's always going to be 0. But when 0 is divided by any non-zero real number, it's always 0. Now, how about when you have a 7, for example, divided by 0? Well, if I take my calculator out, 7 divided by 0, it gives you an error. Okay, all calculators will do some sort of error. And the way you can sort of imagine it is if you have like 7 people, if you have like a cake and you're celebrating a party and 0 people show up. It's kind of a sad party. Okay, so when you divide by 0, it'll always give you a mistake or an error. Okay, and the definition says you split. All right, division is really splitting. So if you split something into 0 parts, it's not possible. Okay. Alright, so moving on, it says here for the expression 3 divided by x minus 2, what value for x is non-permissible? Meaning what x value would you or could you put in here so that the denominator would be 0? Now, why would we want to look for that? Well, we were trying to find all numbers that will make this rational expression impossible to put in a calculator. Well, what we want to do is, if we know when the denominator is 0, it's going to give us a problem. Well, let's find out when the problem occurs. So what we will do is the denominator we will set equal to 0. We do a little bit of algebra. We would know that if x were allowed to equal 2, all right, if x were allowed to equal 2, the denominator would be 0. Well, we can't allow that to happen. Okay, so what is the non-permissible value? The definition is any value that makes the denominator equal 0. Okay? It says here, write a rule that explains how to determine non-permissible values. Well, that's actually super simple. In order to find what the non-permissible values are, what we do is we set the denominator equal to 0 and then solve. Okay? If we set the denominator equal to 0 and then we solve for the variable, what we do is then we set the variable so that it can't be that number that we just solved for. Okay? We can't allow that number to happen. So let's do a couple of quick examples. It says here, determine the non-permissible values for each rational expression. Well, all I do is I focus on the denominator. Well, since everybody's a product, all right, if everybody's a product in the denominator, that means if b were allowed to equal 0, then the whole denominator is equal 0. So therefore, we don't allow that. The same is for c. If c were allowed to equal 0, the denominator would equal 0, and that would be a problem. So we don't allow that. Okay? So that's simple enough, right? What we did is we set each individual factor equal to 0. We solved, and then we don't allow it. So the next example, we have 2 factors. The first factor is x plus 2. So what we do is x plus 2 is equal to 0. If we move the 2 over, x is equal to 2, that's the one we don't allow. Okay, x can't equal 2. The other factor, x minus 3, same thing. X minus 3 is equal to 0. If we move the negative 3 over to the other side, we can't allow it to equal positive 3. So my non-permissible values are x can't equal to 2 and x can't equal to 3. Next example, we have y squared minus 4. But if you remember from our previous class, or unit, it's 2y squared. We could factor that to y plus 2 and y minus 2. Now those are the individual factors. We set each individual factor equal to 0, and we set it equal to 0. So y plus 2 is equal to 0. We can't allow y to equal negative 2. So we say the non-permissible value is y is not allowed to equal negative 2. Now the other factor, y minus 2 is equal to 0. Y is equal to 2. We can't allow that, so the non-permissible values are y can't equal to negative 2 and positive 2. Okay? So moving on. Again, it's the same process, but now notice that the denominator looks slightly more complicated, but we already know from previous units we can factor these. Okay? So I'm going to just focus on 2x squared plus x minus 10. And one of the factoring strategies we talked about was if this is not 1, we are going to multiply the leading coefficient with the constant, and then we draw our little x. 2 times negative 10, that's negative 20. And then our middle term is 1. So what two numbers add to 1 and multiply to negative 20? Hopefully you would agree that it would be 5 and negative 4. And what do we do with these two numbers? Oh, we split the middle term. Okay, so now all we're doing is we're trying to factor the denominator. So this becomes 2x squared plus 5x, right? We got it from that value, and then minus 4x, and then minus 10. And the strategy that I taught you was, okay, what we're going to do is we're going to group these, and then we're going to take the greatest common factor out. So what's the greatest common factor out of the first pair of numbers? Hopefully you would agree it's x, and that leaves you with a 2x plus 5. And you take a look at the second terms. What's the greatest common factor? You can pull out of negative 4x minus 10, but it has to guarantee a 2x plus 5. Hopefully you would agree it's negative 2. That would again leave you with 2x plus 5. And notice that we have a repeating factor. Well, we factor that out one last time, so it's 2x plus 5, and then x minus 2. Now we have two factors, and we set each individual factor equal to 0. So it's 2x plus 5. We set it equal to 0, and we do a little bit of algebra. We move the 5 over, and then we divide by 2. X is going to equal negative 5 over 2. But if we allowed it to equal negative 5 over 2, it would set the denominator equal to 0, and we can't allow that. So the very first non-permissible value is x can't equal negative 5 over 2. And the other factor is x minus 2. I'm not going to bother showing you the work. Hopefully you would agree if we allowed x equal to 2, the denominator would equal to 0. So we can't allow it to equal to 2. So we say we can't allow it to equal to positive 2 as well. And those are my NPV. Alright, so we're going to start using NPV, non-permissible values. X is not allowed to equal negative 5 over 2, as well as positive 2. I'm going to skip the second one, because all you're going to have to do is remember how to factor that and set it equal to 0. So to save time, I'm just going to factor the last one, m squared minus 9. That's just the difference of squares. That's m plus 3, m minus 3. And what I'm going to do is I'm going to set it equal to 0. I'm going to set each factor equal to 0. So m plus 3 is equal to 0. I'm going to solve. M is equal to negative 3. But we can't allow that because it's a non-permissible value. The other factor, m minus 3, is equal to 0. I move the negative 3 over, it becomes positive 3. Can't allow that. So the non-permissible values are m is not allowed to equal plus or minus 3. Okay? Moving on. Rational expressions with two variables. Okay. So the strategy is exactly the same. I just focus on the denominator, 10x minus 4. What's the greatest common factor we can pull out? So 10 5x minus 4. If I take a look, I think I can pull a 2 out of both terms. 2 bracket 5x minus 2. Well, if I set this to 0, that doesn't make a whole lot of sense because it's just a number already. So there's no issue because there's no variable. Whereas 5x minus 2, we can set that equal to 0. And we're going to say that x is equal to 2 over 5. If we allowed it to equal 2 over 5, that would set it equal to 0. I apologize for the lawnmower in the background. So the only non-permissible value is that. So there was a little bit of a typo here, and there should actually be a y here. So let me just make sure that we get that. Let me just erase that. It should be 4y. So what we're going to do is, again, we're going to factor out the greatest common factor, which is 2. And that leaves me with a 5x minus 2y. And it doesn't really matter that there's two variables. This term is one whole factor. Okay, we always set factors. We always set factors equal to 0. So we're going to go 5x minus 2y is equal to 0. 5x is equal to 2y. And I'm going to divide both sides by 5. And that leaves me with x is not allowed to equal 2 over 5y. And this is totally acceptable. So now you can have infinite number of answers, but x is somehow related to y. Okay? So the non-permissible value is x can't be some proportion of y. Alright, so what we're going to do is we're going to simplify the expression. Now, simplify the expression means, is there a common factor in the numerator and the denominator? Well, let me just shrink this a little bit so you can sort of see. 25x squared minus 4y squared, well, that's actually 5x plus 2y, 5x minus 2y. Right? That's a perfect, oop, there's a typo there too. That's 25x squared minus 4y squared, so that's a perfect square. That's a perfect square with a difference. And we know from a previous unit we can split the difference, 5x plus 2y, 5x minus 2y. All divided by 2, bracket 5x minus 2y. And hey, what do we notice? We have a factor, 5x minus 2y, and another factor, 5x minus 2y. They can cancel out. And yes, we can still simplify. 5x plus 2y is the only thing left in the numerator, and the denominator is 2. But don't forget, even though we've eliminated one of the factors, right, due to simplification, the non-permissible value is still x can never be allowed to equal 2 over 5y. Now, part C says evaluate. Evaluate says x is equal to 0.8, y is equal to 0.5. Well, sorry, 1.5. Well, that's easy. All we have to do, right? All we have to do is we have the simplified version. The simplified version was 5x plus 2y in the numerator divided by 2. And we are going to evaluate. Well, that becomes 5 times 0.8 plus 2 times 1.5 all over 2. And if you use your calculator, I won't bother wasting your time. This works out to 4 plus 3 divided by 2 is equal to 3.5. So even after simplification, we can still evaluate, assuming that we're given the values for all the variables. Okay? Hopefully that makes sense.